In this video, we're going to be discussing distance, speed, and time. So our first example, John travels from Dublin to Cork at a speed of 90 kilometers an hour. So if he leaves at noon and arrives at 2:45, how far apart are the two cities? We're told it took him 2 hours and 45 minutes. So if we convert this to a decimal, 45 minutes out of 60 is going to give you 0.75. So that's how we get that 2 hours 45 minutes is 2.75 hours. So then we can use our DST triangle. To find distance, we multiply speed by time. So we go 90 kilometers by hour. So we multiply 90 kilometers per hour by 2.75, and we get 247.5 kilometers. Our next question. Usain Bolt ran the world record for the 200 meters in 2009 in Berlin. So he ran the race in 19.19 seconds. We want to know what his average speed was in both meters per second and kilometers an hour. So time, take this out of the equation, it's going to be distance divided by speed. So we can divide 200 by 19.19 to find that he travelled roughly 10.4 meters per second. We can then convert this speed into kilometers by dividing by 1,000. Dividing by 1,000 writes this number here as this. So it turns it from meters per second to kilometers per second. To convert this to kilometers per hour, we need to multiply the number by 60, so we can find the number of kilometers in a minute that he travels, and then multiply again by 60 to find the number of kilometers he travels in an hour. So once we do that, we get this result here, roughly 37.5 kilometers an hour. He also hit a top speed of 12.4 meters per second in his 100-meter world record run. So what speed is this in kilometers per hour? We do the very same thing. We're going to divide 12.4 by 1,000 and then multiply by 60 and by 60 again. Doing that, we're going to get 44.6 kilometers an hour. Suppose he'd started the 100 meters at exactly this speed. What time would he have ran if he had maintained this speed for the entirety of the run? To do that, we take the time out of the equation, we divide the distance by the speed, 100 divided by 12.4, and that would have given us 8.06 seconds. So suppose Katie gets on a Lewis at 14:27. She takes the tram all the way to Parnell Street, which takes 40 minutes from her house. But there's a delay of 37 minutes when the tram becomes stuck. At what time does she arrive? This seems like quite a wordy question, but this is very similar to what you'd find in an exam. Very few numbers, lots of English. So what are we trying to do? We're going to rewrite this. Doing that, this is what we have. She sets out on a 40-minute journey at 14:27. There's a 37-minute delay. When does she arrive? We add 40 minutes to 14:27, we're going to get 14:67. Of course, we only have 60 minutes in an hour, so we need to convert one of the 60s on this side over to an hour on this side. That makes it 15:07. Then we add 37 minutes to 15:07. We find that she arrived at 16 minutes to 4. So a good rule of thumb here is to apply that same method to every single question that has plenty of English. If you can rewrite the question with far less English, then it might make the question clearer for you. Here's a snippet of an exam question that has come up before. Car A, car B set off from a starting point. Again, more English than we need. They travel the same route. They travel 70 kilometers. Car A travels at an average speed of 50. Car B travels at an average speed of 45. How far will car B have travelled by the time car A has arrived? We need to know the time first. That'll tell us how long it's taken car A to get to destination D. So, time is the distance divided by the speed. Car A is going to take 70 divided by 50, which is 1.4 hours to arrive. Now, at that time, because car B is travelling slower, it's going to be still moving. So we now need to find the distance that it has travelled in that time. So its speed is 45, and the time it's taken is 1.4 hours. We're going to multiply the speed by the time to get the distance. Doing that, we find they're 63 kilometers into their journey at that time, 7 kilometers away from the destination. One last question. So Mary lives 700 meters from football practice and cycles there. Okay, we don't really need to know any of that. She leaves at 18:05, cycles for 300 meters in 2 minutes. She stops for 5 minutes to talk, and then cycles the further 400 in 2 minutes. We want to draw this on a graph. This is the graph here. How did we do this? She left at 18:05, so we need to denote that the line starts at 18:05 here. So she travelled for 2 minutes, and she travelled 300. So the next data point we should take is 2 minutes onwards from 18:05. So we go 2 minutes across this way. Then we come up the distance she's traveled. So she's traveled a distance of 300 meters. We're going to put the next dot here, directly above here. We can join a line up between those 2 points. So she stops then for 5 minutes. So we move absolutely no distance, so we're not making any movement in the y direction here. She stops and she stays still until 5 minutes later when she moves off again. When she does that, she travels 400 meters. So what we're going to do is come up here and note that she's traveling as far as 700, but no further. How long does it take her? She takes 2 minutes to travel that 400 meters. We find where we are here, and we come across 2 meters again. Come straight up, and there's our dot. Join up those 2 points, and that's your full graph. We're then asked to use the slope formula to find our speed over the last 400 meters. So why does this work? Well, if you look on the left hand side, what we have here is distance on this axis. We have time here. So the slope formula is y2 minus y1 over x2 minus x1. y2 minus y1 is going to give us a distance. 500 minus 300 will give you 200 meters. x2 minus x1 will give you a time. 1813 minus 1805 will give you 7 minutes. Doing that, dividing distance by time, you're going to get a speed. Our speed over the final 400 meters is going to be given by these 2 data points here, 1812 and 300. So she set out at 1812 at the distance 300 from her house, and she arrived at 1814 at a distance of 700 from her house. Putting these into the formula, 700 minus 300 is 400. 1814 minus 1812 is 2 minutes. 0.4 kilometers divided by 0.033 hours is going to give us 12.12 kilometers an hour.